Okay, let's continue. We were talking in section 2.2 about all the different types of lines that we can have, and let's do a quick review of all the different equations that can come with that. Remember, one of the most important things about a line is its slope, and so between any 2 points, x1, y1, and another generic point, x2, y2, the slope, often referred to as the rise over the run, is equal to the change in the y's over the change in the x's. And as a formula, that is given as y2 minus y1 over x2 minus x1. We have then three different ways that we can write the line. Okay, so three equations to write a line. Number one, our favorite one, is known as the slope-intercept form. That is where y is equal to mx plus b. It's called the slope-intercept form because the slope is given as the coefficient on x, and the intercept because we can read the y-intercept as 0, comma, the constant b. Okay. So remember, the y-intercept is not just b, it is an ordered pair 0, comma, b. We also have the slope-intercept form of the line, the point-slope form. So given any ordered pair x1, y1, does not necessarily have to be our y-intercept, we can create the equation of the line using the formula y minus y1 is equal to m, the slope, times x minus x1. We also have the standard form of a line. And that comes in the form ax plus by is equal to c. So what distinguishes this is that on one side we have variables, and on this side there is only constants, so no variables. And we also have the condition then that a, b, and c are integers. Okay. So, for example, we would want to clear fractions and not have rational numbers. All right, so that's the review. And now we need to talk about special cases of a line. Okay. One of them would be vertical lines. Okay. All right. So let's say we have these points, -3, -5, -3, -1, -3, +3, and -3, +5. All right, so our line will go through these points. we need to determine the slope of the line. So first, let's graph. So we have point A. Let's say this is negative 3. Then approximately down here will be negative 3, negative 5. Okay, we'll make it true by labeling it. Okay, this is point A. We can also look and plot this point negative 3, 1, which we'll say is approximately there. So negative 3, negative 1, we'll call this point B. Notice both of those points are in the third quadrant. Okay. We could also have negative 3 and then go up positive 3. We'll call this point C. And lastly, negative 3, positive 5, which will be approximately up here. Okay, so all of these points could be connected. Okay. And this is our line. Now, the equation is, well, the question is, what's the equation? And if we're to get the equation of the line, we also need to know the slope. So let's try the slope. Okay. Now I only need any two pairs to determine the slope. So I suggest we work with C and D because there's at least some positives going on here. Okay, so slope is the change in the y's, y2 minus y1, over the change in the x's, which is x2 minus x1. So in this case, we will have y2 is 5, and x2 is negative 3. Now, I need to subtract from the formula, and then I will take y1 here, which we'll use c, which is 3, over x1, and here I'll have to be careful and put it in parentheses. Now, simplifying up top, 5 minus 3 is 2. And below, we have minus 3. Here, I'm subtracting a negative, so that will become a positive 3. So in the end, we have 2 over 0. And this becomes a problem for us, mainly because what we have is a division by 0. And that leads to a problem of being undefined. So the slope here is not defined. And that makes sense, because if you were thinking about slope as a way to walk up and down something, we imagine this to be a vertical wall, and that's impossible to walk up by yourself. It is an undefined slope. So vertical lines come in a form, a special form, and it turns out they are going to be x equals lines. Because you can see what was common to all of these was the negative 3. So in this case, the equation of this line is x is equal to negative 3. Horizontal lines are a different story, so let's do an example just like that. Okay. and see the differences. So this time our points will be -2, -2, 0, -2, 3, -2, and 5, -2. So first, let's graph. So, if this is the point A, let's call this -2, and this -2 will lead to 0, a 3, and a 5. Okay. So point A happens at -2, -2. Okay. And we'll label it to make it true. Here we have B. Okay. This is the point 0, -2, so I go nowhere in the x, and then down, -2. So this is the point 0, -2. Point C, we go over 3 units in the x and down 2 in the y. So this is 3, -2, and that's the point C. And lastly, point D, over 5, down -2. So now we see that these lines, these points could be connected and would fall on this line, which is a horizontal line. And let's determine the slope. So M is y2 minus y1 over x2 minus x1. Again, I think I'll work with C and D because at least there's a positive coordinate there. So y2 is given as -2, and let's see here. Y2 is -2, and x2 is 5. Okay. Then we subtract from the formula. And I need to put in y1. Again, I'll be careful and put in the parentheses, and minus 3. So if we simplify this, up top, we will have -2. The negative and negative will become positive. And down below, we'll have 2. Which, simplifying up top, we have 0 over 2. And here's a different story. 0 divided by anything but 0 is equal to 0. So the slope of this line is 0. And you can imagine if we were walking along it, it would be like walking along a nice flat surface. And we could put that in y equals mx plus b. We could also use y minus y1. Okay? So what we have here, this is a y-intercept. So that means b is equal to -2. So using y is equal to mx plus b, then the equation of our line must be from here, 0 times x plus -2 from here. So in the end, we have that y is equal to, well, 0 times anything goes to 0, and adding a negative 2 is just negative 2. So that is the equation of this line. The other way you can see it is when you look at the coordinates of the ordered pairs, the y coordinate is staying the same. It is the constant thing. So for all values of x, y is equal to negative 2. Okay, so those are two special cases of lines. Now we have other types. We move on to talking about lines and relationships that lines have with each other. So, for example, if we give a definition for a parallel line, well, parallel lines, okay. Parallel lines have, one, the same slope, and different y-intercepts. Then they will be parallel. There is a second case. Okay, so that would be something like this. Two lines that look like this. That they would have the same slope, but different y-intercepts. The other case is where we have no y-intercepts. For example, two vertical lines would be parallel. Okay, but these would have the same slope. This would have undefined slope. We could give a definition for perpendicular lines. Let's see. Some notation. I might, when I denote parallel lines, I might do something like this or something like that to denote parallel. Okay. Now, for perpendicular, perpendicular lines form right angles. And so the easiest case is even to just look at our coordinate axes. This is one vertical line. Okay. Here's one horizontal line. And in between them is a right angle. This is 90 degrees. And I often put the box there to denote 90 degrees. Okay. But this will be true. Okay. So remember here the slope is undefined. And here, the slope is equal to 0. Okay. So this is an x equals line, and this is a y equals line. In this case, they both happen to be x equals 0 and y equals 0. But we can imagine if this rotates, that again we would still get some form of perpendicular line. So this line will have a slope, and it is possible for me to draw in a line that is perpendicular to that. And what will happen in this case is that they will have negative reciprocal slopes. And what does that mean? Well, so for example, this is an increasing line. It will have a positive slope. If it has a slope of positive 2, remember we could think about this as 2 over 1. Okay. Then this slope, if it is a perpendicular line, will take the reciprocal which is 1/2, and we'll make it negative. Now let's try and do an example where we can determine if the lines are parallel, perpendicular, or neither. So for example, let's say we have the line 3y is equal to negative 4x plus 3, and the line 3x minus 4y is equal to 8. This is an example of a line that's written in standard form. Notice the variables are on the left side, the constant is on the right side, and the coefficients are integers. So we are asked to determine, is this parallel, is this perpendicular, or is this neither? So basically what we need to find then is the slope, because if they are going to be parallel, they should have the same slope, even if it's undefined. And if they're to be perpendicular, we need negative reciprocal slope, or the special case of undefined and 0 slope. So let's see what we can determine. Okay. So the easiest way to find slope is to put both lines in y equals mx plus b. If we can solve this for y, that is the coefficient on y is 1, then the coefficient on x will be our slope. So with our first line, we're very close. We have just 3 times y, but we need a single y. So if I divide everything by 3, then what will happen is the 3's will cancel there. We'll have y is equal to a negative 4x over 3, and now plus 3 over 3 becomes 1. And I'd like to rewrite this so I can clearly see what the coefficient on x is. So we have y is equal to, I hope we can agree, that if I take negative 4/3 of x, negative 4/3, and multiply that x, these two are the same. If you need to, you can think about x as x over 1 plus 1. Because if I multiply these back together, negative 4 times x gives you negative 4x, and 3 times 1 is 3. So the slope here, that is the slope of the first, so I'm going to put a little m sum 1 down there, is equal to negative 4/3. And now we know the slope of the first line. Let's determine the slope of the second line. I'm looking ahead here and I see that the coefficient on y is negative 4y. So eventually I'm going to have to divide through by negative 4y. However, I can avoid that by adding 4y to both sides. That will make this go to 0. So we're left with 3x is equal to 8 plus 4y. I'd like y by itself, so let's subtract 8 from both sides. So 3x minus 8, here we will go to 0, is equal to 4y. And now when I divide by 4, I'm only dividing by a positive 4, not a negative 4. And using the same reasoning now, that 3x over 4, well, that's 3/4 x minus 4 goes into 8 2 times. So that is the slope that belongs to our second line is 3/4. From this, then we can compare. Are they parallel? We're asking ourselves this. And the answer to that is no. And why is that? That is because these are different slopes. So if they are to be parallel, they must have the same slope. Are they perpendicular? And I'm going to use this notation here. Okay. So are they perpendicular? That is, can they form right angles? I'm asking myself that question. And the answer to that is yes. And the reason is because they have negative reciprocal slopes. One is negative 4/3, the other is the positive value 3/4. So these are perpendicular. Let's try another example. Okay, so for example, 2y minus x is equal to 10, and 2y is equal to x plus 4. Again, we'll start looking for the slope of the line. So I need to solve for y. So let's add x to both sides. So that 2y is equal to 10 plus x. So that 2y is equal to x plus 10. We can do that because remember addition commutes. And now I need to solve for y. Oops, let's put it in. So the 2's will cancel, and we're left with now x divided by 2 is the same thing as 1/2 x, and 2 goes into 10 5 times. Okay. So that is our slope here. The slope for the first line is 1/2. Over here, we've almost solved for y. Again, we'll divide by 2. The 2's will cancel here. We have y is equal to, again, x divided by 2 is 1/2 of x. And now we're adding 2. So from here, we can see that the slope of the first line is the same as the slope of the second line, which is 1/2. So we're very much on our way to determining if these are parallel lines. Okay. So we have to determine what the y-intercept is. We'll read that from here. Our y-intercept is the ordered pair 0, 5. And here, our y-intercept, because this is in y equals mx plus b, can be read from here, is the ordered pair 0, 2. And from there we can make our conclusion These are parallel lines because they have same slope and different y-intercepts. So that's great, and that's how we determine if they're parallel or perpendicular. And if they met neither the criteria for parallel or perpendicular, then we would say they're neither. But what's more helpful is if we are given a line and a point, can we determine a line that's parallel through the point? Okay, so let's do this example. Okay, we want to find an equation for a line parallel to the line 5x plus 7y. So we want to find an equation for a line parallel to this line that passes through the points -1, -2. So we are determining an equation of a line. Okay? We are creating a new equation in that case. And I need to finish this off. 5x, I'm sorry. This is 5x is equal to 7 plus y. Okay. I didn't have an equation before. Okay. So when you're determining an equation, number one, we need to know a slope. Okay. And we can get that from here. Okay. Because the line needs to be parallel, it will be the same slope as this line. So 5x is equal to 7 plus y. Solving this for y, we have 5x minus 7 is equal to y. Now this is in the form y is equal to mx plus b. So we can read that our slope is 5. So this will be the slope of our line. Okay. Now if we're going to determine the equation, it needs to pass through this point. So this is our point x1, y1. And to determine our equation, we will just use y minus y1 is equal to m times x minus x1. So here we go. Y minus y1 is negative 2. Remember your parentheses is equal to 5 times x minus x1. And now we'll simplify. Remember, these will turn to positives. Okay. So we'll get y plus 2 is equal to 5 times, and these will also turn to positives, plus 1. And we can simplify this, distributing through. Okay. Y plus 2 is equal to 5x's plus 5. And subtracting 2. We have that y is equal to 5x plus 3. And that does it. That's the equation of our new line that is parallel to this line. They have the same slopes, but clearly they have different y-intercepts, and they will pass through this point. Let's try one last example, because we also care about not just being parallel through a point, but perpendicular through a point. Okay, so now our equation, we want to be perpendicular to the line 5x minus 3y plus 4 is equal to 0. Okay. Right. If we're going to be parallel to these, I'm sorry, not parallel, perpendicular to this line, we're going to have to find the negative and the reciprocal slope. Okay. And we need to go through negative 4, positive 1. So this is where we will determine the slope. Okay, so 5x minus 3y plus 4 equals 0. I'm just recopying it. All right, let's get to y. Okay, get it by itself. So I can do that by adding 3y to both sides. So on this side, we'll be left with 5x plus 4 is equal to now 3y. And now we need y by itself, so I can divide by 3. So in this case, we'll have y is equal to 5/3 times x plus 4/3. So that is this line written in y equals mx plus b. And from here, then we can read that the slope of this line is 5/3. But that's not the slope we need. Okay? We need the negative reciprocal slope if we're going to be perpendicular. So our slope will be negative and then the reciprocal. And here's a point for us to go through. Okay? Now that we have slope, we now need a point. So this will be x1, this will be y1. And we can use the formula y minus y1 is equal to m times x minus x1. Filling in, y minus y1 is 1 is equal to m, which in this case, Rm is negative 3/5 times x minus x1, which is negative 4. Again, be careful about the parentheses. So simplifying, we'll work inside the parentheses. Y minus 1 is equal to negative 3/5 of x, and now plus 4. Okay? Subtracting the negative becomes plus 4. And let's simplify this and put it in y equals mx plus b. So we can distribute this through and this through. So y minus 1 is equal to negative 3/5 of x, then plus, now I'm going to just distribute this so we can see this happen, negative 3/5 times 4. Okay. But remember, we can think about that as 4 over 1. And here, if there was any canceling that could occur, I would want to do it. Unfortunately, there's not. So we just have, from up top here, y minus 1 is equal to negative 3/5 of x. Now, adding a negative will turn it positive, and multiplying across, 3 and 4 is 12, and 5 times 1 is 5. We're almost there. We simply have to add 1 to both sides. But in this case, I'd like to add 1 as 5 over 5. Okay. Either way, I'm adding 1. The reason why I'm doing that is because this fraction, I will need to combine this fraction with the number 1, so we'll need a common denominator. So y is equal to negative 3/5 of x minus 12/5 plus 5/5 is minus 7/5 of x. And this is the equation of our line. That is perpendicular to this line that passes through this slope.